To finish up our discussion on factoring, I want to talk about a couple of special polynomials. In this video, we're going to focus on the difference of squares and the sum and difference of cubes. We're going to start with a difference of squares, and I want to start this discussion by multiplying out these two binomials. Notice that they're the same binomial, except one has a plus and one has a minus. We'll use what we often call the foiling technique to do this. If we multiply the first two terms, we get 9x squared. The outer two terms, you get minus 6x. The inner two terms, you get plus 6x. And the last two terms, if you multiply them together, you get minus 4. You'll notice that the minus 6x and the plus 6x cancel each other out, and you're just left with 9x squared minus 4. So what did we just learn? We just found out that 9x squared minus 4 is the exact same thing as 3x plus 2 times 3x minus 2. So if we have this polynomial, 9x squared minus 4, and we want to factor it, which we often want to do in this class, this is the factored form of that polynomial. Okay, so if we start with 3x plus 2 times 3x minus 2 and we want to multiply it out, we're going to get 9x squared minus 4. If we start with 9x squared minus 4 and we want to factor it, we end with 3x plus 2 times 3x minus 2. Sometimes we want to go in this direction, other times we want to go in this direction. It all depends on the problem. But notice what just happened here. 9x squared is the same thing as quantity 3 times x squared, and 4 is the same thing as 2 squared. So in other words, if we have anything, some things squared minus some other thing squared, we can factor that out just by doing the first thing plus the second thing times the first thing minus the second thing. In this box right here is what we call the general form for the difference of squares factoring. And just as a really quick example, what if we had 4x squared minus 1? Well, we might recognize this 4x squared as 2x squared. You might recognize 1 as, well, just 1 squared. And there's a minus in between these two things. So this is a difference of squares. We know from our rule above that we just take the first thing that got squared, add it to the second thing that got squared, and then do the same thing with a little subtraction in between. And that is how you factor 4x squared minus 1. One last note before we move on. This only works with a minus. If that sign is a plus, it's not going to work. There is no way to factor a sum of squares. Okay, let's move on to the next one. We want to talk about difference of cubes now. Now this might seem a little bit crazy, but let's see what happens when we multiply this binomial by this trinomial. We multiplied the a by the 3 terms in the trinomial, and now we're going to multiply the negative b. When we do that, we'll notice that we have an ab squared here and a minus ab squared here that are going to cancel each other out. We can also notice that we have an a squared b here and a minus a squared b here. And those will cancel each other out. And what we're left with is just the a cubed minus b cubed. Okay, so what did we learn? Let me write it the other way. We learned that a cubed minus b cubed is the same exact thing as a minus b times the quantity a squared plus ab plus b squared. So again, if we happen to have something cubed minus something else that's cubed, we can factor it now into the right-hand side. And as we had known in the past, if we had something like this binomial times this trinomial, and the a's and the b's are organized just like this, we can multiply it out and we're going to end up getting this difference of cubes. Okay, as a quick example, say we want to factor this polynomial right here. It's 8x cubed minus 27. Well, your job as a student is to recognize this 8x cubed as 2x, that whole quantity, cubed. And then you'll also recognize that 27 is the same thing as 3 cubed. There's a minus sign in between these two perfect cubes. So what we have ourselves is a difference of cubes, where that thing right there, that 2x is going to be our a, and that 3 is going to be our b. Now that we know this is a difference of cubes, we know it's going to factor into a binomial, this one right here, times a trinomial, this one right here. We just have to fill out what our a's and b's are. So let's write it out. A is 2x minus b is 3. Then we have a squared. I'm just going to write it out as a squared plus a times b is going to be 2x times 3 plus b squared is going to be 3 squared. Now we don't always need to write that step out, but I figured for demonstration purposes I would do it once. I'm going to simplify this trinomial over here. The binomial is already simple, so I'll just copy it down. 2x, the whole thing squared, is going to be 4x squared. 2x times 3 is plus 6x, and 3 squared is 9. So we started with 8x cubed minus 27, and if we wanted to factor it, we can, because it is a difference of cubes, and it factors just like that. Okay, we've got one more special type of polynomial to factor. It is called a sum of cubes. And this is the funny thing I want to multiply out this time. You'll notice that there are some sign changes from the last problem. If I multiply the a by every term in the trinomial, and then I multiply the positive b this time, when you write it all out, you'll notice that you get a minus a squared b and a plus a squared b, which will cancel. And you get a plus ab squared and a minus ab squared that will cancel. Everything cancels here except for the a cubed plus b cubed. So what we demonstrated here was that a cubed plus b cubed is the same thing as what we started with, which is pretty neat because if we have a polynomial that looks something like this, the sum of two cubes, we can now factor it into these two pieces. Let's take a look at an example. If we want to factor x cubed plus 8, our job is to recognize x cubed as, well, x cubed, and to recognize 8 as 2 cubed, and there is a plus in between these two things. So what we have is a sum of two cubes. We look at our sum of cubes formula here and we say, oh, that's how the sum of cubes factors. So this x is going to be our a for this problem and this 2 is going to be our b for this problem. And we can factor this thing out just using the formula straight above it. A plus b is going to be x plus 2. A squared is going to be x squared. Minus a times b is going to be x times 2, which you can also call 2x. Plus b squared, which is just going to be 4. That is how you can factor that sum of cubes using the formula just right above it. Okay, I'm going to cut it off there. There's a worksheet for you to fill out with this video. Make sure to get it finished and turn it in class, and I will see you there.